Hi, my name is Vlado Damjanovski from ViDi Labs in Australia. I have over 38 years of experience in CCTV. Some of you may know my name through the books I've published on CCTV for the last 25 years. I've been doing consultancy for a lot of major projects in Australia and overseas. I have produced many different tools for people to be able to improve their work in CCTV, such as test pattern generators, applications for various calculations in determining pixel densities, software for measuring quality of the cameras, and one product that a lot of people may not know about is the test chart. So what you can see there is the latest of our test charts, version 5. But my company has been producing test charts since the very first book published in 1994-95. So this is basically the updated version, fifth generation, which includes a lot of important details for measuring modern high definition, ultra high definition or 4K megapixel cameras. So in this short video, I would like to introduce you to the test chart concept and principles and why you should use one to improve your system installation, your system project. What you see over there is the A1 format, and at the bottom is the A3 format, which is the one that is probably most popular because it's easier to ship around the world. I will just use the test chart to explain details in a few seconds, but first let me explain why would you need a test chart. Well, test charts are traditionally used in broadcast television for many years. There are particular types of test chart that the broadcast engineers have used to adjust their cameras to make sure their setting is optimum, or to perhaps check which of the 2 or 3 cameras produces the best results. Similarly, in CCTV, we can do the same thing by using a test chart. We can verify which of the chosen cameras for a tender, for example, has better performance or better resolution or better color reproduction, or perhaps less noise. Any of the reasons why you need to put a CCTV system in a particular project, why do you need to choose a particular camera, can be verified or compared with other products by using a test chart. Why test chart? Simply because the test chart is static image made to have a lot of details of different kinds for different purposes, which usually give you details of every aspect of the camera. I will explain more in details for this one, but just before I go there, very briefly, what do you need for a test chart to be used successfully? Of course, test chart is the first thing you would need. Whether it's A1 format or A3, that's up to you. Certainly A3 can do almost all the things as the A1. It's just A1 is a bit more generous in terms of space, so it gives you a bit more breathing space, so to speak. You put the camera a bit further away, you can use different lenses and so forth, but all the things that you can do with the A1, you can do with the A3 format. So irrespective of the size, the concept and the principles are the same. So you need a test chart, you need controlled light. The controlled light in our case is a special modification of LEDs where basically we can also dim the illumination levels. And I highly suggest that you can also, or you should do the same thing. So as you can see here, we can go to almost 0, which means we can actually measure the illumination level. We typically recommend a good quality lux meter for you to verify what is the illumination level you get of the test chart. So you obviously need a tripod to put your camera and the test on the tripod. It's a nice thing to be able to protect the environment or the area where you're testing from external light. In our case, this is with a black sheets all around and non-reflective area. So when you're measuring the illumination, the reflectivity of the chart. We know it's measured only by the chart. It's not affected by anything else. And obviously, for this particular short video, we're having illumination to illuminate me. But in real experiment or real test, there is no other light other than the test chart light. Now I'll demonstrate that and show you what it looks like. And let me turn off the light of my reflector. So that's roughly what it looks like without the external light. And then clearly you can go down to maybe 0.1 of a lux or even lower. So let me put this back so I can explain the other details. So controlled light, lux meter, protected from external influences, a tripod that can be used to position the camera at any distance. And most important is the positioning of the camera to be perpendicular to the test chart. So optical axis of the camera has to be perpendicular. Once you do this, obviously you go through your system, usually VMS. So I've got here a network a cable that goes in the same test chart. High definition aspect of it is shown on this computer. So just to show you that this is a real life image, you can see my hand there. So the key is to adjust the view of the camera by obviously focusing on it, by choosing the certain resolution mode, in this case HD 1920 by 1080. So the test chart section is chosen so you fill up the whole image of what the camera sees up to the areas that are shown with the black triangle corners, and I will explain how that works. So once you do that, you're recording the camera with your VMS system with whatever resolution you choose, providing you put down the details, what you do. And as you're recording, you can change aspect ratios, you can change compression, you can change whatever parameters you want to change, as long as you know when you've done it. So when you export the image, you know that that happened when you use AGC, for example, 10, or wide dynamic range off, or for example, noise reduction 2, or something like that. So the point is, you're exporting the image, and that image you can then analyze as an image using any photo editing software. You can just look at it directly. Like certainly, depending on what your VMS can offer, I can simply zoom in here and I can see details by zoomed in, providing I've got the other camera or the other setting of the same camera to compare with. So this is a visual comparison of a image that camera produces at known illumination level with a known test chart, which has got high quality details reproduced. And then you can actually have quite a good understanding of which of the two cameras you chose to compare actually is better in one section or the other, or maybe all sections. So test chart is highly controlled, precise reproduction, both in resolution and color, of the pattern that the manufacturer of test chart has produced. In our case, we produce something specifically for the CCTV industry, where I will explain all the details, which one does what, where you actually constantly using as a reference. So you've got constant reference with a controlled and constant light when you compare it. And that makes a big difference when you're determining the quality of a camera. Instead of just buying a camera, positioning it to look through the window and seeing whatever you see outside, and then put another camera. You can do comparison of two cameras next to each other concurrently like that, but still there are a lot of variables there that you may not necessarily be certain of. It may be a car movement. It may be a reflection of the window of some car on one camera, not on the other. When you have a test chart, you actually see everything the same all the time. So the test chart produced in A3 format are easier to ship. So of course, you are more than welcome to order whichever of the two you want. However, we are saying that this is the most popular product because of obviously the weight, the shipping cost, and of course this is much much cheaper test shot than the A1. But again, they are doing the same function. The quality of the print is the highest photo quality we could get. The printers that we use to print this are color calibrated, which is very important. The surface is a matte surface in order not to reflect light when you're measuring, so you don't have reflections. So, in other words, it's something that can be used for at least 5 to 10 years. If you don't leave the test chart, I should say, if you don't leave the test chart outside in the sun, where it may be affected by UV and heat and so forth, it should last 5 to 10 years. But certainly after a while, the color pigments will start deteriorate if they're exposed to bright light. If they're kept indoor and protected, like when you're not measuring, then certainly it's expected to be at least 5 to 10 years, which is more or less sufficient until the new technology brings new new cameras. But it's not limited just to CCTV cameras. With the test shot, you can test. I've tested smartphones, mirrorless cameras, DSLRs, and so forth, because the concept and the principles are the same in terms of what you're measuring. Okay, so let me now explain what we have in our test chart. So what you will see through the image and how you measure it and what do we measure. First and foremost, you can do many of these evaluations visually, manually yourself. Of course, you have to have a trained eye. You have to know what you're looking at. But the test chart is designed to reasonably easy show you the effect of certain detail of the camera, perhaps resolution or compression artifacts. So if you look at the test chart, it's actually composed to have all aspects ratios to be tested. The actual corners here that we've got with the yellow triangle and black, yellow and black, yellow and black is 16:9 aspect ratio, which is what we are seeing there now, with what is shown here. But as you can see here, because it's 16:9, there is an area above it which is not shown and below it which is not shown. If you have a camera, let's say a megapixel that is not necessarily 16:9, it could be 3:2. So you can test here, there is a 3:2 marker where you can test 3:2, or some cameras may have 4:3 aspect ratio, like in the old time of standard definition, which was 4:3. So we've got 4:3 aspect ratio up to here, and that's another limiting area for testing. So first and foremost, we've got at the top of the HD in this instance, at the very top, we've got this yellow ruler, which is literally a ruler in case you want to measure something, or maybe you want to determine the letters. So we've got here letters that are going in points in terms of printing quality, from 26 points down to 1 point size, going from A to Z, A, B, C, D. So some people use that to determine how far I can see with this camera if the other one compared with is looking at the same thing. What we have here as a practical application test chart measurement is, first at the top, we've got the so-called television color bars. Television color bars are known to all people that have worked in the television industry, which are actually fully saturated red, green, and blue colors, starting from white to yellow to cyan, then green, then magenta, red, blue, and black. So these are, for example, white is 255 bit level of red, green, and blue in order to get fully saturated white. As most of you would know, in CCTV, we typically use 8-bit color encoding system. So whether we use JPEG, for example, as a compression, or H.264, or motion JPEG, they're all 8-bit colors, which means we are really working with color space of red, green, and blue from 0 to 255. So this is white. Then the yellow would be, there is a coordinate for red 255, the green is 255, the blue is 0, and so forth. So these are saturated colors as such, which can be seen when you actually bring into the screen. You can actually measure it. And we have software that does that automatically. So I'll explain that later as well. Then the next is a bar that actually is a continuous change of colors from red through green to blue. But because the printing is such a high quality in terms of printing resolution, this is much higher than the resolution of any of the CCTV cameras we've got today. 4K or maybe 5 megapixel, 10 megapixel, even 8K. This is higher resolution than that. So what that means is, in real life, when you look at the chart, it's very difficult to see any disturbance or discontinuity of changing the color. So it's very smooth and continuous transition. So what happens is when you get the camera to look at this image and convert it to digital stream, obviously it's compressing it. In that compression, we've got not only sampling, but also quantization. So in other words, the luminance levels are quantized in terms of discrete steps. So that could be a level for green, for example, 235, then you've got 236. This is digital, 235, 236. But in between, there may be values that in this chart are actually present. But depending on your setting on the compression, when you play it back, you actually can see quite clearly distinct steps, how the color changes. Rather than continuous, you will see steps. The stronger the compression is, or the more artifacts from compression you have, the more these steps will be obvious. And that makes it easy for you, even though if you don't know the theory behind it, when you play with the camera in different settings, let's say you choose settings of 4 megabits per second H.264, and then you want to compare that with 3 megabits per second, or maybe 2, then when you play back and see the images, you will see that the one with the higher compression will have a bit more obvious steps. So whether you accept that or not, it's up to you, but certainly you can compare different camera quality that way. So this is in a way really unique in the industry. This is our invention, how with a continuous change of tones of colors, you can actually verify or compare different compression quality artifacts. Then we have a similar bar at the bottom, which is only black and white. So it goes from black to white to black. And in a way, this is also showing you compression artifact if you want to, because you can quite clearly see this is also very continuous and smooth transition. But you can also check with this so-called gamma curve of the luminance conversion of the electrons or illumination that falls on the sensor, how that is converted into electrical signal and how we see it. Then you've got the standard 11 steps grayscale, which is basically from the black to the white. We've got 11 steps. And that can also serve for determining the gamma of a camera. But it also be useful. It is also used for adjusting camera contrast brightness, which also is reflected into receiving end as camera contrast brightness. The idea is for you to be able to distinguish all 11 steps, because each one is 10% different than the other. That's why we've got 11, because we start from 1 and we go to 90% or 100%. So this is black, 0 basically luminance to 100% white. That means if you cannot distinguish, let's say, the first two or the last two, it may be that the brightness and contrast or the gamma setting in your camera or in your monitor is not good enough for you to recognize all shades of gray. The idea of any video image or photographic image, any photographer, when he takes picture, always wants to see maximum number of deviations from the darkest to the brightest. Not details lost in the darkness, but we want to see as much details as possible from the darkest to the brightest, which is why we want to see all the steps of gray. And you'll be amazed to see how many cameras actually can be finely adjusted to get much better result by seeing what you're actually getting. Again, by changing either gamma or contrast or brightness. Then we have most important thing in the center and the corners is the so-called Siemens sine wave stars. So these circles are based on the latest recommendation of the standard 62676-5, where I contributed as well. So this is the reason why we updated to version 5. Before, version 4 was known to many people, but this is now 5, specifically made to comply with the latest standards. So the sine wave Siemens star is made with rays which are not changing contrast from black to white as a clean cut between black and white, so abrupt jumps from black to white, but actually they're changing the brightness and contrast as a sine wave. And that's very useful for measuring the resolution, which in our case, we measure with the latest recommendations where resolution of any camera is defined as line pairs per picture height. We no longer measure television lines, which was the case in the analog CCTV. We measure it with line pairs per picture height. So if you use this test chart, which is designed with 144 rays of black and white, you can either do it manually or we can do it with the software. Now, I didn't mention that, but we actually have a manual for the measurement and how to use the CCTV test chart, which you can freely download from the ViDi Labs website. So if you go to vidilabs.com, under the tab of the test chart, you will see a lot of videos and explanations of many things that I'm briefly touching on now. But in the manual, we've got much better description of how and why you do it and how you do it so that you can read and study it at your leisure. But the point is you can do manual. You can manually measure it. Once you get the image, you can put it through the Photoshop photo editing software, and then you can measure certain things and that will calculate for you. You can calculate based on what formula is given in the test chart manual, and you can see what is your line pairs per picture height for that particular camera. Now, obviously, you can measure the same thing in the corners so that you know whether the resolution in the corners is lower and how much lower than the center. Typically, any camera, not just CCTV, the best resolution is in the middle because optics is usually made with the best performance when it's in the projecting in the middle. But some cameras have good lenses which are as good in the corners. Also, you can see the distortions, optical distortions, which are very common in CCTV. Unlike professional photography where distortions are minimal kind of thing, in CCTV we often have barrel distortions, we've got distortions of the corners, and this is very obvious when you get a test shot. It's not so obvious when you put the camera outside looking at the street. People are distorted, but you don't know how much are they distorted. With this, you can actually see that. So that was the few basic parameters. Then we have very important thing, which is unique also for our test chart, the UK Home Office faces. Now, UK Home Office has advised a series of computer-generated faces, which was contained in the, again, latest standard 62676-4 in this instance, where they advise how you can determine face identification capability of a system. This is also explained in our ViDi Labs test chart. So I welcome you to read and apply it because it's a very useful way to do it. But this is a kind of included in the test chart as well, where we are positioning test chart, which go from 1 o'clock to 3 o'clock until 11 o'clock and progressively reduce the size of the head. And actually, we have a formula how you can calculate the pixel density equivalency of such a head size, and they are randomly positioned. So the idea is for you when you're testing camera and wanting to make sure this is sufficient for face identification at a certain distance, we actually want you to go through it and find out, okay, the last face I can detect and I can see it's this face and that could be maybe C2 face. So as you can see at the bottom, there are actually all the references in order, which is A1, A2, A3, B1, B2, B3, C1, C2, C3, as advised by Home Office. These are faces which are different skin tones, so for all races, basically, to be fair and equally applicable. But they are computer generated so that you don't need to apply copyright or you don't owe anybody's privacy. You don't affect anybody's privacy. These are computer generated to be similar but different. So A1, A2, A3 may look similar to you from a distance, but when you actually look at them closer, you will see there is a difference. So the point is for you to be able to guess which of these A1, A2, A3 is, let's say, somewhere here. And I'm not telling you where the key is here, so it's written on the test chart. It's a random order, but the idea is for you to be able to determine from whichever camera you're testing I can determine face up to 9 o'clock. And then for that, the key tells you, okay, this is approximately, let's say, 70 or 80% face identification ability of that camera. If you switch parameters on that camera, if you switch to another camera, you may drop down your quality to here, which typically could be associated with a less resolution or maybe higher compression or incorrect filtering. Any of these can affect the thing. So that's for the faces. Then we also have so-called Macbeth test chart. Macbeth is known to photographers, and this is for testing colors which are non-saturated colors. We have here colors which are kind of similar to typically human faces or natural objects with exactly known color coordinates in red, green, and blue space. So if you take an image of this test chart with your camera, depending on the color balance of the camera, depending on the source of light, which is in this case our illumination there, you may have a variation, a deviation from the actual spectral coordinates there. And that actually is measured by our software. So in our software that I mentioned, we offer for the first 10 images free software report for your cameras. That means you can use that offer. Of course, if you have a big number of cameras, then we obviously will come up to some agreement or costing. But the point is we write a complete report on whatever camera you have by exporting a JPEG or TIFF or bitmap image of the H.264 or H.265, whatever you use image. Once you send it to us, we run it through the software, and the software produces report about resolution, about the color accuracy and deviation of the colors, about the gamma. We also measure the signal to noise ratio from the 50% patch in the grayscale, because in that we also include the compression artifacts in the signal to noise. So all these things we produce basically for free for the first 10 shots, as long as you've got this test chart and you give us and send us the image of that and we give you a report. Again, this is unique in the world. Nobody has offered anything like that for CCTV industry. So I'm just informing you that this is something that once you know how useful it can be, I urge you to make most of it. What else we've got here? We've got also the number plates. Number plates are progressively reduced, and there is exactly physical millimeter size of that, which in the manual we explain how you can convert to pixel density, but certainly it's very simple and obvious here to know how far you can see which number plate starting from AB123CD to QR345ST or UV678WX. Then you can see, yeah, okay, if I want to have number plates recognized, this camera allows me to recognize even the top smallest number plate compared to the other one because of whatever you chose, either different lenses or different pixel count or different compression. So you can compare objectively. Last but not least, we also have money, card, and coins. This is typically for banks and casinos. And this is, in this case, half of the scale of the real money. So what it means is if you go to a bank and you want to set up a camera to recognize, identify money, all you can do, you don't have to do any calculations. You put the test chart at the counter, put the camera and start coming down until you start recognizing all the money or the chart or the test or playing cards if you want clearly. And the point is this is half of the size, which means whatever height you find that is sufficiently good for your recognition of the money, you can then duplicate or double that height because this is half of the size of the actual money. If you come down to 1 meter above the teller with a particular camera and lens settings, then we know that if you go 2 meters height, real money, because this is half of the real money, can be recognized. In the A1 size test chart, the actual money and cards are 1-to-1 scale, real life scale. But this one, we had to find a way to put more details by reducing them, and knowing the fact that this is half of the size, you actually can still do the same thing. This squiggly lines is for measuring line pairs for picture height with the old method which we use for measuring television lines, but now they are converted into line pairs for picture height. I explain more on this in my seminars, but also in the manual, you can also see explanation about why the new measurement is LP/PH, or line pairs per picture height. So the test chart comes on a hardboard, usually with Velcro, so you can easily mount it on a wall. Of course, you can mount it whichever way you want. Usually protected with two hard pieces of wood, so that doesn't get knocked, because that's one of the common problems we have in shipping worldwide. But a lot of people are using it, and this is already being recommended by the standards. So it's not something that cannot be compared with somebody else in some other country. So a lot of people around the world are using it. I will just say that there is more things to be tested with this test chart. Another invention we have, which is unique, we actually made this test chart useful for testing when we are rotating the test chart. And this is useful for when you want to see moving object and see what are the artifacts of the compression or of the camera setting when you pick up a person that runs, or maybe number plates, car that are passing by. So this is a modification we advise, easy to do. Obviously, we're not sending it as part of the test chart, but we've got a stepper motor here, which is mounted in the center. So the test chart rotates with certain revolutions per minute, which you can control. So it can be anything from maybe 1 revolutions every second down to 0.1 every second, or even more if you want. Basically, when the chart revolves and you're taking pictures, you can quite clearly see the artifacts from the faces moving, from the number plates moving, from the money moving. And in our manual, we also have an example and formulas how you can calculate the equivalent motion detected by that testing of a real object moving in front of the camera 10 meters away. So this is something that again is unique, and if you're interested, you actually can do testing in your lab, in your workshop, without having to go on site and do the actual testing of how far this car passes by and whether I can capture the number plates or not. You can actually simulate it with this by following the steps and explanations we have in that. Test chart is a necessary tool for making the most out of your cameras. Even if you have already decided on cameras, you've got plenty of variables there that you may be able to decide what is the best for different applications. But certainly if you have a new project, a tender, for example, and you have choice of 3 cameras you want to buy, obviously I hope people do not decide just on the price, but obviously you want to see which camera has what quality. So my suggestion is always get sample of each cameras, get the distributor to give you sample of these cameras. And if you have a test chart, you can easily actually compare them and you can decide which is the best for you. So it's a tool that you probably should think very seriously about. I've been, as I said, working with test charts for over 25 years, and certainly the latest version has the most functional and the most varied applications and most varied methods of testing many different things, not just visual appearance, but as I explained, all the things that digital cameras have today. So if you've got any questions, please, you can send me an email, vlado@vidilabs.com. But I suggest first have a look at the manual. You will find a lot of things in there, much clearer, illustrated better than what I've managed to tell you in these few minutes. Thank you.